This is a discussion of the perpetual growth valuation equation that you see here in the center of the screen. The two main parts of that equation, I believe, are the relative positioning of the valuation date, which we're going to talk about in the general sense as being a time t, against the first cash flow in your timeline, which is one period later than the valuation date, in other words, a t plus 1. And also the relationship between the first of the cash flows against the perpetual series of growth. Now, that became a bit labored. I think it's best to dive into the first of these four examples on the top left-hand side of the screen, and perhaps I can explain a bit better what I'm talking about here. In the simplest example, top left-hand side, we have a valuation requirement at T0 for a perpetually growing series of cash flows, which begins at T1 with a value of 72, and that will then grow forever at 5% per period. And I have, although it's not necessary, just for illustration purposes, I'm going to fill in some of these future cash flows, each of which is 5% bigger than the one before, just so that I can illustrate something about the linkages, the logical linkages between these cash flows, starting with that one there, growing by 5% in this case to that one there, and then growing to that one there, and then so on to infinity. And just hold that thought for the time being, that we have a series of linked cash flows starting at a particular point, in this case at T1. The valuation formula tells us that at T0 we need the T1 cash flow, which is 72, and we divide that by the required rate of return, which is 0.12, minus the growth rate, 0.05. And that is a very straightforward calculation to 1028.57. Let's turn our attention to the example in the top right-hand quadrant. In this situation, we are given, as usual, the required rate of return and the growth rate. What is different here is that we have a cash flow at T0, and this cash flow here is something that one needs to be careful about. It obviously is useful information and we need it, but it does not directly become part of the valuation. Why is that? That is because when we are looking for a value at T0, we need the first cash flow after T0, not the cash flow at T0. And in this situation, we have enough information for us to determine what that first cash flow is. And again, I'm going to be filling in some somewhat unnecessary numbers just to illustrate a point. That cash flow is 24.13. That one is 25.09. That one is 26.10. And if I could use, again, the same kind of representation as I used over here, I'm going to put a circle around the first of my cash flow stream that begins the linkages of that perpetual series of growth. In this case, each of those grows by 4% from the period before, and it carries on forever. Back to the valuation. What we are now dealing with is a pretty clear visualization of a series of growing cash flows beginning at T1, which is exactly where we want to identify the first of that perpetually growing series. We can write that down, 24.13. The required rate of return is 0.115, and the growth rate is 4%, and that allows us to calculate a value at T0 of 321.71. Before we leave this example in the top right-hand quadrant, let's reflect briefly on something that is sitting unmentioned in the background about that first cash flow. And that is that in this particular situation, it happens to be the case that the growth rate of 4% began at the beginning of the timeline. And therefore, it is mathematically the case that that first cash flow happens to be defined by that equation there. And you will see that equation sitting above the line as the numerator in many textbooks and university courses, where they in fact define this particular valuation equation in terms of that numerator. Now that is a problem. Let me show you why. We turn our attention to the bottom left-hand quadrant. In this situation, we have a T0 cash flow, we have a perpetual growth rate, we have a required rate of return, fair enough, but I'm creating a complication here. And that complication is that in the first year, the cash flow stream grew by 50% to 41.4. And it's only from that point there that we have the perpetual series of 3% growth rate. And I'm going to fill in some of those numbers again, just for illustration purposes. And if we follow the practice that we've been doing up until now, we are now aware that we have a series of cash flows beginning at that point there and carrying on with that pattern of growth in perpetuity. We have a little problem though, or do we? And that little problem, that inconvenience, is what about this plus 50% growth over here? And this is very easily dealt with by simply paying attention to the valuation equation, which after all tells us that the value at T0, which is what we are after in all these examples, is determined by the first cash flow. And that first cash flow is 41.4 in this situation. And we have the return, and we have the growth rate, and we determine a value of 530.77 for this. And I think just to pause briefly and reflect on what is going on here is that in this situation, the inconvenience of a very high growth rate in the first period turns out not to be a problem at all, as long as you embrace that particular formulation of this equation, that you say that the T0 value is driven by the first cash flow down the timeline at T1, and you don't care at all what the growth rate, if any, might have been between T0 and T1. If you tried to import this particular construct, I'm now underlining that CF0 1 plus G in the top right-hand quadrant, if you tried to take that into this situation here, you'd get into a horrible mess, because of course that constant growth rate doesn't begin in this situation at T0, it begins at T1. But the neat elegance of this equation in this formulation tells us that there's nothing to be alarmed about there. And finally, the bottom right-hand quadrant demonstrates the more generalizable formulation of this equation, that you don't always have the luxury of starting at T0. Yes, we want to get there eventually, but this equation is transportable anywhere you like down the timeline. In this case, we have a perpetually growing series of cash flows, which inconveniently begins only at T5, and that's fine because we then visualize our chain of perpetually growing cash flows beginning at T5. The relationship between each of these is that they grow forever per period at 3.6% each time, and it's not a problem at all. We now know that we stand one period prior to the beginning of that linked series of growing cash flows, and we are careful with the subscripts. We just remind ourselves where we are, and we say if we're going to value T4, we need the cash flow at T5, that's one period down, R minus G, which gives us a value of 139.54. And following that, it becomes an absolutely simple proposition of doing a present value calculation of that and bringing that back to T0 using the required rate of return. And that is 88.05. And I hope you found this short video interesting and informative, and thank you for watching.